Hi, my name is Philip Hall, and I'm a graduate architecture and planning student, and I work with Samantha Schmidt and Dane Brown, and they are both environmental engineers. We based our project pretty heavily on two things, and the first was theory, and the second was that I was working with two environmental engineers. So the theory that we worked with comes from MCHARG and his 1969 environmental design classic called Design with Nature. And in that text, we use three things that he emphasized to try to really infer and put into our design. And those were, one, that you need to design with an environmentally conscious approach to land use and development. Two, that the human interaction, to emphasize the importance of human interaction with the environment. And he talks about this concept of the natural being and the connection between humans and nature. And then three, emphasizing the natural utility and value of the landscape. So we actually wanted our design through nature to actually have some sort of utility or function to it. And so through Ian McHarg, we kind of formulated a theoretical question. And Ian McHarg had a lot to do with discussing preservation of undeveloped natural landscapes. And so our question then was, how can his theory impact the redevelopment of an existing urban site which really doesn't have any, or has very little existing natural landscape left on it? So we had a couple of objectives. Our objective was to consider the previous and existing natural site conditions and design an environmental restoration project, whether literal or symbolic, that one, enhance the interaction between man and nature, two, utilize natural functions of the land, and three, incorporated an environmentally conscious building design. So when we first took a look at the site, there was actually very little that was left that we actually considered natural. But what was left on the site was two groves of trees, which were located right here and right in this area here. And then there was also a buried creek which runs east to west through the entire site. And there really wasn't much else to go on. In Ian McHarg's book, he talks about urban suitability and the land that should be developed, and from least to greatest, he talks about flatlands, forests, steep slopes, aquifers, aquifer recharging areas, floodplains, marshes, and surface water. So the two things that we had that fell in that category were the woodlands and the creek. So our design strategy sort of had three parts. The first was to focus on the detail or connection between the natural and the urban landscape. This is sort of our concept image, and it's your image number 1 on the second page of the handout. This is from a museum by Jean Nouvel in France, and it has a garden wall connected to the structure, and I just like the image how it shows the actual detail or progression from the natural to the built environment. The second part of our design strategy was to look at the transition from the inner natural core of our site, which is going to be the creek, which we have as a biofiltration swale, and how that then progresses out into the urban edge. And then the third part of our design strategy was to play with the elements of the strict urban grid, and the free form that you find in natural elements. So the main design constraint of our site really had to do with the creek which runs through it, which Samantha is going to talk about. Which is what we decided to do with that, instead of restoring the creek itself, was to have a symbolic design gesture and make it into, like I said, a biofiltration.
Okay, as Phil said, one of our main options, I guess one of our first options when we first started talking about it, was actually to restore the creek, which is currently piped by a 96-inch clay pipe, so a pretty large pipe. There are three main problems that we saw with this. The first was the quantity of water that would be running through the site. Currently, I'm sure all of you know, the city of Cincinnati is under a consent decree, and this site actually goes into a combined sewer system. So the quantity of water that would run through the site could actually overwhelm the site, would be a problem in the combined sewers, and flooding could also be an issue on a commercial development like this. The second was the quality of water. Upstream, the water isn't very aesthetically pleasing. Also, there's a lot of debris and garbage that runs through the creek, so that wouldn't necessarily add to the aesthetics of our site if we let that water flow freely. The third issue was funding, which was probably the biggest issue of all. Any sort of federal funding that is granted to creek restoration typically comes if you're improving water quality or if you're going to increase habitat in that stream. Obviously, with a stream like this running through a commercial site, you're not going to really fund either of it. So we decided to go with a more symbolic gesture, which was the bioswale. The bioswale would decrease water quantity and increase water quality. Going through a bioswale like this allows us to develop a low-impact development, which is one of the main things that cities typically look for, especially when they're under their consent decrees. Bioswales will help filter pollutants and can actually help improve the water quality of the receiving streams downstream, as well as what water quality on the site. It has been shown that bioswales can help filter out pollutants and remove up to 70% of the total suspended solids that run through the site. Another benefit to the bioswale is cost. A lot of times constructing a swale like this can cost less than your typical curb and gutter, and also your underground pipe systems. So basically, we know this is a pretty large swale. We know that it's kind of a straight shot. We didn't have a lot of room to meander it. So a couple things that we would do to help protect the swale. We have more than plenty of room. Philip was able to provide us more than plenty of room in case of flooding issues. However, we really don't think that would be an issue because we designed the swale to accommodate the 50-year storm. So basically, to reduce velocities and erosions, what we could do is add rock check dams. You could either do rock or you could actually do wood as well. Wood tends to be more aesthetically pleasing through swales like this. And we could also do plunge pools where throughout the swale your sections would actually get a little bit wider, which would reduce the velocities. Another thing that we talked about is the swale is oversized actually because of Madisonville being a combined sewer network. We wanted to decrease the amount of runoff as much as possible. So what Dane's going to actually touch on is the green roofs and the pervious pavements that we were using, which actually will provide less water getting into the swale. So.
All right, because this is such a large site and we are